If the James Webb Space Telescope's latest images impressed you, what you are about to see will completely shift your perspective. A new space telescope has quietly begun returning images so detailed, vast, and revealing that scientists admit they were caught off guard. The Euclid Space Telescope has just released its first light images, and they show far more than just beautiful galaxies. They expose structures we barely understand, patterns molded by invisible forces, and a universe that appears much more complex and unsettling than we anticipated. Tonight, I'm going to walk you through exactly what Euclid has captured, why astronomers call these images revolutionary, and why understanding them is genuinely terrifying. Stick around until the end, because this is only the beginning of what Euclid is about to reveal. Euclid is not your average space telescope. It wasn't designed to focus on a single nebula or zoom in on one spectacular galaxy. Its true mission is far more ambitious and far more unsettling. Launched by the European Space Agency in July 2023 to Lagrange Point 2, 1.5 million kilometers away, Euclid was built to map the universe on a scale never attempted before. Its ultra-wide field of view captures enormous sections of the sky in a single observation without sacrificing incredible resolution. This means Euclid can see individual galaxies clearly while simultaneously revealing how millions of them connect into vast cosmic structures. What makes this truly disturbing is that Euclid isn't just mapping light. It is mapping the influence of dark matter itself, using subtle distortions in galaxy shapes caused by gravitational lensing. In other words, Euclid is showing us the skeleton of the universe, a structure shaped by something we cannot see and do not fully understand. When Euclid returned its first mosaic of the southern sky, scientists were stunned by the sheer scale of the data. In a very short observing window, the telescope captured 260 images covering an area 500 times larger than the full moon. Once stitched together, these images revealed millions of stars and galaxies. And yet, this represents only about 1% of the final map Euclid is expected to create. That realization alone is unsettling. You aren't seeing a finished picture, but a fragment of something incomprehensibly larger. Researchers can zoom from the most massive cosmic structures down to individual galaxies without losing clarity, revealing how matter is organized across vast distances. This mosaic is more than just a photograph. It is a preview of the largest, most detailed 3D map of the universe humanity has ever attempted. It immediately raises uncomfortable questions about how little of the cosmos we have actually explored. One of the most disturbing revelations from Euclid's first images comes from the Perseus cluster, located roughly 240 million light-years away. This single image displays over 1,000 known galaxies alongside more than 100,000 distant background galaxies. But the real shock arrived when scientists looked closer. Euclid discovered more than 630 previously unknown dwarf galaxies hidden within the cluster, objects so faint they had escaped detection until now. This matters because dwarf galaxies are extremely sensitive to the gravitational influence of dark matter. Their shapes, positions, and distortions act like tracers, revealing where dark matter is concentrated. The fact that so many were invisible until Euclid arrived suggests that dark matter's influence may be far more intricate than previously believed. The universe doesn't just contain dark matter, it appears to be built around it. Euclid's images are not only reshaping our understanding of large-scale structure, they're also exposing chaos at smaller scales. In galaxies like NGC 6822, Euclid revealed low metallicity stars that resemble conditions from the early universe, offering a glimpse into how galaxies evolved billions of years ago. In globular clusters such as NGC 6397, Euclid managed to resolve faint stars in the outskirts that were previously drowned out by brighter ones, unlocking new clues about the Milky Way's history. And in regions like the Horsehead Nebula, Euclid's sensitivity uncovered evidence of free-floating planets and Jupiter-mass objects drifting without stars, suggesting rogue planets may be far more common than anyone imagined. These images paint a picture of a universe that is not calm or orderly, but dynamic, crowded, and constantly reshaped by forces both visible and invisible. As scientists began stitching together more of Euclid's data, a disturbing pattern became impossible to ignore. Galaxies are not scattered randomly. They are arranged along vast filaments, enormous cosmic threads stretching across hundreds of millions of light years, intersecting at dense nodes where galaxy clusters form. Euclid's images make this structure painfully clear. It looks less like a peaceful universe and more like a gigantic neural network, with matter flowing along invisible pathways shaped almost entirely by dark matter. These filaments are no longer theoretical. You can see their influence directly in the way galaxies bend, stretch, and align. The terrifying part is not their existence, but their scale. This cosmic web dominates the universe, and everything we see, every galaxy, every cluster, every void, is trapped within it, guided by forces we still cannot touch or detect directly. One of Euclid's most unsettling capabilities is its precision in measuring gravitational lensing. By detecting tiny distortions in the shapes of distant galaxies, Euclid effectively reveals where dark matter is hiding. These distortions are subtle, almost imperceptible without Euclid's resolution. But when mapped across millions of galaxies, a clear picture emerges. Massive regions of dark matter bend space itself, warping the light of objects behind them. What makes this frightening is that these massive structures are completely invisible. They emit no light, they reflect nothing, yet they outweigh everything we can see. Euclid is showing us a universe where the dominant form of matter is something we cannot interact with, something that silently controls the motion and fate of entire galaxies. Euclid's reach into deep time adds another layer of unease. Some of the galaxies captured in its first images are more than 10 billion light-years away, meaning their light began its journey when the universe was still young. By observing these ancient galaxies alongside much closer ones in the same frame, Euclid allows scientists to track how cosmic structure evolved over most of the universe's history. What they are seeing suggests that large-scale structure formed earlier and more efficiently than expected. Galaxies clustered faster. Dark matter organized itself sooner. The universe may have grown up far quicker than our models predicted. That forces a reevaluation of how cosmic evolution really works and whether our current understanding of gravity itself is complete. Perhaps the most unsettling fact of all is this. Everything you have just heard comes from roughly 1% of Euclid's planned survey. 99% of its map is still missing. Over the next 5.5 years, Euclid will continue scanning the sky, filling in gaps, sharpening structures, and exposing patterns we don't even know how to look for yet. If this is what the universe looks like at 1% resolution, the full picture may be overwhelming. Euclid is not just collecting images. It is building a dataset so large and detailed that it may force fundamental changes in cosmology, from the nature of dark matter and dark energy to the laws governing the expansion of the universe itself. One of the most unsettling revelations emerging from Euclid's data is not where galaxies are, but where they are not. Vast regions of space appear almost empty, enormous cosmic voids stretching across hundreds of millions of light years. But Euclid shows that these voids are not truly empty. They are shaped, bordered, and defined by the same invisible forces that build galaxy clusters. The distribution of galaxies around these voids suggests that dark energy may be actively pushing matter away, accelerating the expansion of space itself. In Euclid's images, these voids feel less like gaps and more like pressure zones, regions where the universe is being stretched apart. The terrifying implication is that the large-scale structure of the cosmos is not just passively expanding, it is being actively rearranged. Euclid was built not only to map dark matter, but to hunt for dark energy, the mysterious force believed to be driving the accelerated expansion of the universe. By measuring the positions and redshifts of billions of galaxies, Euclid can track how the expansion rate has changed over time. Early analysis of its first data hints at subtle deviations from expected models. These deviations are small, but persistent. They suggest that dark energy may not be constant as once assumed, but evolving. If confirmed, this would fundamentally alter our understanding of cosmic history. The force shaping the fate of the universe may be more dynamic, more complex, and less predictable than we ever imagined. As Euclid's datasets grow, scientists are facing a new kind of challenge. The sheer scale of the information is overwhelming. We're no longer talking about thousands or millions of objects, but billions of galaxies mapped in 3 dimensions. Human intuition struggles at this scale. Patterns that define the universe are too large to grasp without advanced algorithms and artificial intelligence. In a sense, Euclid is forcing us to rely on machines to understand what machines have observed. This introduces a strange feedback loop where our knowledge of the universe increasingly depends on systems interpreting data beyond direct human comprehension. The terrifying aspect is not the data itself, but how much of reality may exist beyond what our minds can intuitively understand. Perhaps the most disturbing implication of Euclid's early images is what they suggest about the foundations of physics. Dark matter, dark energy, gravitational lensing, accelerated expansion. Together, these phenomena dominate the universe. Yet, they're explained by theories filled with gaps and placeholders. Euclid's clarity exposes how much of our cosmic model rests on unknowns. We can map the effects with incredible precision, but we still do not know the true nature of the forces behind them. Euclid is not just revealing the universe. It is revealing the limits of our understanding, showing us a cosmos where most of what matters is invisible, unexplained, and only known through its influence on everything else. At first glance, Euclid's images are breathtaking. Galaxies glow, nebulae swirl, and star clusters sparkle with an almost artistic balance. But the longer scientists stare at these pictures, the more unsettling they become. Beauty, in this case, is not comfort. It is precision. Every sharp edge, every perfectly traced filament, every delicate distortion is evidence of forces acting relentlessly across unimaginable distances. These images are beautiful because the universe is obeying rules with brutal consistency. Gravity never rests. Dark matter never loosens its grip. Expansion never slows down. What feels visually calming is, in reality, the signature of a cosmos that is constantly pulling, bending, and stretching everything inside it. Euclid's data strongly reinforces a disturbing idea. Galaxies are not the architects of cosmic structure. They are the decorations. The real builders are invisible. Dark matter halos form first, collapsing under gravity long before stars ignite. Only later do galaxies form inside these halos, lighting up regions that were already shaped by something we cannot see. Euclid's ability to map galaxy shapes alongside gravitational lensing makes this hierarchy impossible to ignore. The visible universe is riding on a hidden framework, one that dictates where galaxies can exist and how they evolve. The terrifying implication is that everything we can observe is secondary, almost superficial compared to the unseen mass controlling the cosmos. One of the most mind-bending aspects of Euclid's observations is how it compresses cosmic time into a single frame. In one image, you can see nearby galaxies as they are today, distant galaxies as they were billions of years ago, and faint structures formed shortly after the universe began. Past and present coexist in the same photograph. This means Euclid is not just imaging space, it is imaging history. Scientists can track how galaxy shapes change, how clustering evolves, and how dark matter's influence grows stronger over time, all by comparing objects at different distances. The terrifying part is realizing that what we call now is just a thin slice of a much larger cosmic process, one that has been unfolding long before Earth existed and will continue long after it is gone. As Euclid continues its 6-year mission, researchers are beginning to suspect that its most important discoveries may not be the ones it was designed to make. The telescope was built to study dark matter and dark energy, but its unprecedented resolution and scale are already revealing anomalies, unexpected alignments, and subtle patterns that do not fit neatly into existing models. History shows that when a new instrument opens a window this wide, surprises follow. Euclid may end up forcing revisions not just to cosmology, but to fundamental physics itself. The truly unsettling possibility is that the universe Euclid is revealing may not be fully explainable with the tools we currently have. One of Euclid's most unsettling strengths is its ability to show the universe at two completely different scales simultaneously. In a single observation, the telescope captures vast cosmic structures stretching across millions of light years, while also resolving fine details inside individual galaxies and star clusters. This dual vision reveals something deeply uncomfortable. The same invisible forces shaping the largest filaments of the cosmic web are also influencing how stars form inside small, irregular galaxies. Euclid is showing that the universe is not layered neatly from big to small. Everything is connected. Large-scale gravity dictates local behavior, meaning that events happening across incomprehensible distances can quietly shape what happens inside a single galaxy. The universe is not modular, it is systemic. Many of the regions Euclid photographed were already known to astronomers. Perseus, the Horsehead Nebula, nearby globular clusters. And yet, Euclid revealed features in these familiar places that no one had ever seen before. New dwarf galaxies, hidden star clusters, and faint stellar populations drowned out in previous surveys. This raises an unsettling question. If we were so wrong, or at least so incomplete, about regions we thought we understood well, how much are we missing in places we barely know at all? Euclid is quietly demonstrating that familiarity breeds false confidence. The universe we thought we recognized still has layers we never uncovered simply because we lack the right perspective. Euclid's ability to observe galaxies up to 10 billion light-years away turns the telescope into a literal time machine. The farther it looks, the younger the universe becomes. By combining visible light imaging with infrared measurements, Euclid allows scientists to place galaxies precisely in three-dimensional space and time. This makes it possible to reconstruct how cosmic structure grew from a nearly uniform early universe into the complex web we see today. The unsettling realization is how quickly this structure appears to have formed. Dark matter clumped early. Galaxies followed fast. The universe organized itself with an efficiency that challenges slow-growth models. Euclid is hinting that cosmic evolution may have been more aggressive, more decisive than we ever assumed. As Euclid's early data continues to be analyzed, a pattern is emerging that every astronomer recognizes but never welcomes. The number of questions is growing faster than the number of answers. Each new structure mapped introduces anomalies. Each new lensing signal raises doubts about the nature of gravity. Each refined measurement of expansion nudges dark energy models closer to uncertainty. Euclid is not just filling gaps in our knowledge. It is exposing how provisional that knowledge really is. The terrifying part is not that we don't have answers yet. It is that the universe Euclid is revealing may require questions we don't yet know how to ask. When you take a step back and look at everything Euclid has revealed so far, one thing becomes impossible to deny. These images are not terrifying because they show monsters, explosions, or cosmic disasters. They are terrifying because they show order. A precise, structured, deeply interconnected universe governed by forces we cannot see, cannot touch, and still cannot explain. Dark matter is not a side character. It is the main architect. Dark energy is not a theory in the background. It is actively pulling the universe apart. And gravity, as we understand it, may not be telling the full story. Euclid is forcing us to confront an uncomfortable truth. Most of the universe is invisible, and most of what matters operates beyond our direct perception. Galaxies follow paths they did not choose. Structures form where unseen mass allows them to exist. Even empty space is shaped, stretched, and sculpted by forces older than stars themselves. What feels distant and abstract suddenly becomes intimate because this same cosmic machinery shaped our galaxy, our solar system, and ultimately us. Think about that. We're not standing on solid ground in a calm universe. We are riding inside a vast, dynamic structure built on unknown physics, moving through space according to rules we're only beginning to glimpse. Euclid's images are beautiful, yes, but they're also honest. They show us a universe that does not revolve around what we can see, what we can measure easily, or what makes us comfortable. And this is only the beginning. Euclid has completed just a fraction of its mission. 99% of its map is still waiting to be revealed. If these first images are already challenging our understanding of dark matter, dark energy, gravity, and cosmic evolution, imagine what the full picture will force us to rethink. If you want to stay ahead of these discoveries, if you want to understand what these images really mean instead of just admiring them, make sure you're subscribed. Share your thoughts in the comments, because this is one of those moments where science quietly rewrites the rules. And remember, the universe Euclid is revealing isn't new. It's been there all along. We're just finally seeing it for what it really is. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.